This is SQA Higher Maths. Today we're going to look at the whole of differentiation in SQA Higher Maths exams, especially for the 2023 exams coming up in May. SQA Higher Maths 2015 Paper 1 Question 7 on differentiating a polynomial. A function f is defined on a simple domain by f of x is root x, 3x minus 2 over x root x. Find f dash 4. So we need to get it ready to differentiate. So f of x is equal to root x is x to the half, 3x minus 2 over x times x to the half. So we need to get that all tidied up first. So that is x to the half times 3x minus 2 over x to the 3 halves. And then we can multiply our brackets out to get 3x to the 3 halves minus 2x to the half over x to the 3 halves, and tidying that up even further, f of x is 3x to the 3 halves minus 2x to the minus 1, a half minus 3 halves. Now we can differentiate it, f dash x, take the power down to the front, so it's 3 halves times 3, x to the, take 1 away from the power, so it's a half, minus times a minus is a plus, so plus 2x to the minus 2. Tidying that back up because it was a non-calculator question, so we can substitute 4 in. We get f dash x is equal to 3 3s are 9 over 2 root x, x to the half, plus 2 over x squared. So now we need to substitute 4 in. So f dash 4 is equal to 9 over 2 root 4 plus 2 over 4 squared. That's 9 over 2 times 2 plus 2 over 16. That's just 9 plus an eighth. So we can just write 9 and an eighth if we want as our final answer. SQA Higher Maths 2016 Paper 1 Question 2, differentiating a polynomial. So given that y equals 12x cubed plus 8 root x, find the y by the x. So we need to get it ready to differentiate. 12x squared plus 8 root x is x to the half. So the y by the x, taking the power down to the front, 3 times 12x, take away 1 from the power, squared, plus a half times 8x, take away 1 from the power, minus a half. So the y by the x, 3 times 12 is 36, x squared, a half of 8 is 4, so plus 4x to the minus a half. And there's no reason to make that a positive power because we've just defined the y by the x, so we're done there. SQA Higher Maths 2017 Paper 1 Question 8 on differentiating a polynomial. Calculate the rate of change of d of t is equal to 1 over 2t. So we need to get it ready to differentiate. Always need to do that. So d of t is equal to 1 over 2 t to the minus 1. Do not be tempted to move this 2. That's just a half still. Separate it out. It's just the t that's moving. Once we do that, d dash t, take the minus 1 down, so we get minus a half t, take away 1 from the power, we get minus 2. Then we have to work it out when t is 5. So d slash 5 is equal to minus a half times 5 to the minus 2, or minus 1 over 2 times 5 squared, minus 1 over 2 times 5 squared is 50. So minus a 50th. Just a note, remember, rate of change means differentiate. 2022 Higher Maths, Paper 1, Question 4. Y equals the square root of x cubed minus 2x to the power minus 1, where x is greater than 0. We have to differentiate this expression, so let's get ahead and do that. So our first step, or our first mark, is to rewrite the square root of x cubed is x to the 3 halves. And we've still got minus 2x to the minus 1. If we've written that, we get a mark there for this x to the power 3 halves. We now need to differentiate our terms. So our first mark is for differentiating our first term, which is 3 over 2 x, take away 1 from 3 halves, and that's 1 half. There's a mark there. And then differentiating our second term, minus times a minus is a plus, so it's plus 2x to the power of minus 2, taking away 1. So our final mark is 1 here and 1 for this term here. We do not have to go any further than that in this question. So if you did go further, that's fine, but you don't have to. Differentiating a trig function, SQA Higher Maths 2016, paper 2, question 11. Show that sine 2x tan x equals 1 minus cos 2x, and then differentiate sine 2x tan x. So part A, sine 2x tan x, well, we can change sine 2x to 2 sine x cos x, and we can change tan x into sine x over cos x. So that gives me 2 sine squared x, and the cos x obviously cancel. So then as an aside, remember we've got a cos 2x on the right hand side. Well, cos 2x, using the expansion with sine squared x in it, is 1 minus 2 sine squared x. So we can rearrange that to get what sine squared x is. That means that 2 sine squared x, moving over to the right, equals 1 minus cos 2x. As required. Part B, f of x is equal to 1 minus cos 2x now. So f dash x, differentiating each function, 1 goes to 0. Cos, remember, goes to minus sine, so it becomes plus sine, so it's sine 2x because of minus minus. And then we need to, because of a chain rule, differentiate the inner function, which is 2, so times by 2. So we get 2 sine 2x. Okay, differentiating a trig function. SQA Higher Maths 2018, paper 1, question 3. h of x is 3 cos 2x, find h dash pi over 6. So if h of x is 3 cos 2x, then h, straight away you can just do h dash x is equal to minus sine 2x, well, minus 3 sine 2x, but then we need to times by 2 because we need to differentiate the 2x part as well. So that's minus 6 sine 2x. This is a paper 1 question, so it's an exact value question. So h dash pi over 6 is equal to minus 6 times sine 2 pi over 6, subbing it in. That equals minus 6 times the sine of pi over 3. Or if you prefer to work in exact values in degrees, that would be 60. So that equals minus 6, the sine of 60, root 3 over 2. 6 divided by 2 is 3, so it's minus 3 root 3. And we're done there. Okay, the chain rule. SQA Higher Maths 2016, paper 2, question 10. Given it y equals x squared plus 7.5, find the y by the x. And then part B, hence find the integral of this function, which we'll use our answer to part A to do. So part A, the y by the x is equal to, take the half down to the front, x squared plus 7, take 1 off the power, minus a half, and then we differentiate the bit inside the brackets, which is x squared, so that becomes 2x. So that equals 2x divided by 2 is just x, so x bracket x squared plus 7 to the minus a half. And then try to make it look a bit like our part B, that's x over x squared plus 7 to the half, which is equal to x over the square root of x squared plus 7. Part B says integrate 4x over square root of x squared plus 7, which is very similar. So if I do part B, integrate 4x over the square root of x squared plus 7 dx, well, if I just take that 4 out, I get the integral of x over the square root of x squared plus 7 dx, which I already know is exactly the same as what I found out up here, my differential. This integrated is exactly that. So I can just write the integral as x squared plus 7.5. Simple as that. So that means I've got my answer is 4 times x squared plus 7 to the power of a half. or let's make that neater, x squared plus 7 to the half. I've forgot my plus c, so there we are, plus c, and we're done there. Okay, the chain rule. SQA Higher Maths 2017, paper 1, question 3. Y equals 4x minus 1 to the 12, find the y by dx. Nice and simple, 12 down to the front, 4x minus 1, take away 1 for the power, but then times the bit in the bracket differentiated, in other words, times 4. 4 times 12 is 48, 4x minus 1 to the 11, job done. Okay, the chain rule, SQA Higher Maths 2019, paper 1, question 6. Given that y equals 1 over 1 minus 3x to the half, and x is not a third, find the y by dx. Let's get it ready to differentiate. So y equals 1 minus 3x to the minus 5. So the y by dx minus 5 in the front, 1 minus 3x, take away 1 from the power, so that's minus 6, and then times by whatever's in the bracket differentiated, which is minus 3. So tidying that up, we get minus 5 times minus 3 is 15, 1 minus 3x to the minus 6, and we're done there. Paper 1, question 12 was, given f of x is 4 sine 3x minus pi over 3, evaluate f dash pi over 6, or f dash, differentiate your function at pi over 6. So, f dash x, we can check the front of the exam paper to realise that sine becomes cos when you differentiate it. So you should first of all start by writing 4 cos 3x minus pi over 3. And just for doing that part without actually finishing the differentiation, which I'm going to do in a moment, gets you your first mark. For your second mark, you have to then realise that this is the chain rule. So you've got an inner function of 3x minus pi over 3. So you need to differentiate that and times the whole thing by that. So in other words, if I differentiate this part, that's the constant, so that's nothing. Differentiate 3x is 3. So I need to times by 3. So we get a second mark for realising that and writing down it. We're going to times by 3. And then our final mark, of course, is evaluating it. So I need to tidy it up and then substitute pi over 6 in. So f dash x equals 12 cos 3x minus pi over 3. So f dash of pi over 6. And this is an exact value, remember, because we are non-calculator. But I'll substitute it in first. 12 cos 3 pi over 6 minus pi over 3. We need to tidy that up. So that's 12 cos 3 pi over 6 minus 2 pi over 6, which is 12 cos 3 minus 2 is 1, so it's just pi over 6. Pi over 6, if you prefer to think in degrees, is 180 divided by 6, which is 30 degrees. So it's the pi cos of 30. If you're not sure of what that is, let's draw an exact value triangle. If this was 60 degrees, that would be 30 degrees up here. This would be 2, this would be 1. 2 squared is 4, minus 1 squared is 1, so that gives you 3. So we get the root 3. And we're looking at the cos, so it's opposite adjacent over hypotenuse, root 3 over 2. So you get 12 times the cos times root 3 over 2. 12 divided by 2 is 6, so you get 6 with the root 3 as your final answer. And for all of that extra work, it's 1 extra mark. A bit stingy of the SQA there. So there's our final mark at this point here. Increasing and decreasing functions. SQA Higher Maths 2016, paper 1, question 9. Find the x-coordinates of the stationary points on the graph with equation y equals f of x, which is x cubed plus 3x squared minus 24x, and then find the range of values for which a function is strictly increasing. Part A, stationary points, differentiation, make it equal to 0. Okay, so part A, f dash x, 3x squared, 2 3s is 6, so plus 6x minus 24. So stationary points occur when f dash x equals 0. I would always like that statement and then just make it equal to 0. Taking 3 out as a common factor, we get x squared plus 2x minus 8. So that's 3, double bracket, x and x, 4 and 2, plus 4 minus 2. So that implies that x equals 2 or x equals minus 4. Just the x coordinates, so we're done there. Okay, part B. Determine the range of values for which the function is strictly increasing. So we need to work out when it's increasing, so we're going to do a nature table and work out that. So part B, using our nature table, we're going to go along to the vicinity of minus 4, and then we're going to go along, and then we're going to do the same to 2, and then along. Notice I split this up into 2 turning points, just in case the function is not continuous here. That just saves me any bother. Okay, so that's my x. So my f dash x at this point, well, we already know that it's 0 at these 2 places. So pick a number before minus 4, it's minus 5. And it's always easy to substitute into the factorised form to work this out, but you can just do this in your head or do the work on a bit of paper. I'll do it in my head. So we've got minus 5 minus 2, which is negative, minus 5 plus 4, which is negative. A negative times a negative is a plus, so that's positive. After minus 4, let's just pick any number, pick 0. Minus 2 is 0, that's negative, that's positive. Negative times a positive is a negative. So we already know this one's going to be negative because it's the same idea before 2. After 2, 3 minus 2 is 1, 3 plus 4 is 7, positive times a positive is a positive. So our shape is going up the way, then along the way, then down the way, and for this side it's going down the way, along the way, then up the way. And we have to work out when it's strictly increasing. So it's increasing when x is less than minus 4 or x is greater than 2. Increasing and decreasing functions, SQA Higher Maths, 2018, paper 1, question 15. This is a QE function set of real numbers, and we're given a bunch of information. X plus 4 is a factor. That means that x equals minus 4 is a root. X equals 2 is a repeated root. Well, repeated root, remember, means the turning point is also at that point. So we also have a turning point at x equal to 2 on the x-axis then. F dash minus 2 equals 0 also implies a turning point at x equal to minus 2, but that could be anywhere, so it could be under or below. But then we also know that when it crosses the y-axis, the gradient of the tangent is greater than 0, so it's going up the way after it crosses the y-axis. So we can now start to draw a possible diagram, and this is just one possible answer, but as long as it's consistent with all the information, we'll be fine. So let's put in our minus 4 root. Let's go there. Our minus 2 where it's a turning point, and our 2 over here, which is a repeated root. So drawing it in red to be clear. Since it's rising at this point where it cuts the y-axis, then, and this is a turning point, it must drop down here, turn it minus 2, rise back up, turn it 2 again, and then drop back down, because we also know that 2 is a turning point. So there you go, we have managed to do that. We're showing it that minus 2 is one of the turning points. We've got x equal to 2 here and minus 4, so we've got a possible graph, and we're done there. Increasing and decreasing functions, SQA Higher Maths 2018, paper 2, question 3. A function is defined as a set of real numbers given by f of x is x cubed minus 7x minus 6. Determine whether f is increasing or decreasing when x equals to 2. So we need to work out the gradient of the tangent at x equal to 2. So f dash x is equal to 3x squared minus 7. At x equal to 2, f dash of 2 in other words, we get 3 times 2 squared minus 7. That's 3 times 4 is 12, take away 7 equals 5. And then we need to write a little statement. since f dash of 2 is greater than 0, the function is increasing at x equal to 2. And we're done there. Increasing and decreasing functions, SQA Higher Maths, 2019, paper 2, question 7. Express this in the form p x plus q squared plus r. Now let's complete the square. So for part A, if we look at these two, we can take minus 6 out as a common factor. So we get minus 6, and we get x squared minus 4x. 6 times 4 is plus 24. Take away 25, sitting on the end, and then we just complete the square the normal way on this term. So we've got, that gives you minus 6, half the middle term, x minus 2, all squared, and then immediately take away 2 squared, and we've still got minus 25 on the end. Just be aware that this is all times by minus 6 though, so we need big brackets around it. So that gives us minus 6, x minus 2 squared. 2 2's is 4, 4 6's is 24. So we get plus 24 minus 25 sitting on the end. So that's minus 6, x minus 2 squared. 24 minus 25 is minus 1. Part B says, given that f of x is minus 2x cubed plus 12x squared minus 25x plus 9, show that it's strictly decreasing. So to show that something's increasing or decreasing, we need to evaluate the gradient of the tangent, in other words, differentiate. So let's look at f dash x. F dash x equals 3 times 2 is 6, so minus 6x squared. 12 times 2 is 24, so plus 24x, and minus 25. So we've differentiated it, but notice that is minus 6x squared plus 24x minus 25 is exactly what we were asked to do with something with completing the square on part A. So it's to do with the fact that it's completed the square. So we can now just say that f dash x now equals minus 6x minus 2 squared minus 1. If I pick any number for x here and I square it, I get a positive number. So that means I can then say x minus 2 squared is positive for all values of x. And that means that when I've got a positive times a negative is a negative. Take away another one, gives me a negative as well. So all I need to then say is, therefore, minus 6x minus 2 squared minus 1 is negative for all values of x. So f of x is strictly decreasing. And we're done there. Equation of a tangent to a curve. SQA Higher Maths 2015, paper 1, question 2. Find the equation of a tangent to the curve y equals 2x cubed plus 3 at the point x equals minus 2. Equation of a tangent means differentiate and sub in the number. So step 1, dy by dx. 3 times 2 is 6x squared. So at x equal to minus 2, dy by dx equals 6 times minus 2 squared. 6 times 4, which equals 24. So dy by dx is 24, which remember is equal to our gradient m. When x is minus 2, y equals 2 times minus 2 cubed plus 3. That's 2 times minus 8, add 3. Minus 16 plus 3 is minus 13. So our point is minus 2 minus 13, and our gradient is 24. So that means that y plus 13 equals 24x plus 2. Y plus 13 is 24x plus 48. Or y equals 24x plus 48 minus 13 is 35. And we're done there. SQA Higher Maths 2015, paper 1, question 11 for the equation of a tangent to a curve. Question 11 says the point t minus 2 minus 5 lies in the circumference of the circle with this equation. Find the equation of the tangent to the circle through t. For part A, so the part A is a circle question, and part B says the tangent is also a tangent to a parabola. With that equation, determine the value of p. So let's do part A, circles. The centre of our circle is just minus 8, minus 2. Minus 8 and minus 2. And we've also got our point T, which is minus 2, minus 5. So if we work out our gradient, if we draw a circle for this, there's our C, there's our T, say, out here. That meets the tangent at right angles. So the gradient between C and T is perpendicular to the tangent. So the gradient of CT is equal to minus 5 minus minus 2 over minus 2 minus minus 8. Minus 5 add 2 is minus 3. Minus 2 add 8 is 6. That's equal to minus a half. Therefore, the gradient of the tangent is 2, since m1 times m2 equals minus 1. And then our point, remember, is minus 2 minus 5, so y minus minus 5 equals 2x minus minus 2. So y plus 5 equals 2x plus 4, or y equals 2x minus 1. And we've got the equation of our tangent. Part B says the tangent is also a tangent to a parabola of equation y equals minus 2x squared plus px plus 1 minus p, where p is bigger than 3. Find the value of p. Well, if it's a tangent to that parabola, it means that y equals 2x minus 1 goes into this, so we can just equate them in simultaneous equations. So we can just say that 2x minus 1 equals minus 2x squared plus px plus 1 minus p, and solve that equation to get our x. So moving everything over to the left, we get 2x squared because it's negative. We've got plus 2x, then minus px, and then we've got minus 1 minus another 1, but then plus p, and that would equal 0. Equating all our terms, so we get an x squared, x and a number. You get 2x squared. We can factorise x out here, so we've just got x, so it's 2 minus p times x. And then we've got minus 2 plus p equals 0. So we've got a quadratic, but when you get a quadratic, it only has one solution, or it only touches at one point when the discriminant equals 0. So tangent, therefore b squared minus 4ac equals 0. So our b is 2 minus p, so 2 minus p squared minus 4 times a times c, which is minus 2 add p, equals 0. Multiplying that out, 2 2s is 4, minus 2 times p is 2p, so minus 4p plus p squared. And then you've got 4 times 2 is 8, so it's minus 8 times minus 2 plus p. So you get 4 minus 4p plus p squared plus 16 minus 8p equals 0. So p squared, and then our p terms, we've got a minus 8 minus 4 is minus 12p, and then our constant terms, 16 plus 4 is 20, equals 0. So we've got a quadratic to solve it. We can now factorise, hopefully. If that equals 0, then we get p and p. 10 and 2 to make 12 in the middle, and it'll be minus 10 and minus 2. So p equals 2 or p equals 10. But if you go back to the original question, it says p is greater than 3. So we can disregard that one. So p equals 10 as our final answer. SQA Higher Maths for 18, paper 1, question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write down the coordinates of p, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P already we know is x equal to 0, y equals 5. So when x equals 0, dy by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0 plus 2 equals 2. So our gradient equals 2 and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. X cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 is 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equals 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. Stationary points and their nature. SQA Higher Maths 2016, paper 1, question 9. Find the x-coordinates of the stationary points in the graph with this equation, and then determine the range of values with which the function is increasing. So part A, stationary points occur when f dash x equals 0. So f dash x is equal to 3x squared plus 6x minus 24. So setting that equal to 0. 3 is a common factor, so we get x squared plus 2x minus 8. And we can double bracket that hopefully up quite easily. X and x, 4 and 2, plus 4 minus 2 equals 0. So that means that x equals 2 or x equals minus 4. The 3 doesn't matter because it's just times them by 0. Part B, hence find the range of values for which values of x for which a function is strictly increasing. So we're going to just use a nature table for that. So for part B, looking at our stationary points, it goes along and then hits minus 4 and then it goes along. So there's our first turning point and our second turning point along to 2 and then along. So that's x, and then looking at f dash x. So we can just sub into this one in our heads really. So we know it's 0 here and here. So picking a number before minus 4, let's say minus 5, that'll be negative. Minus 5 take away 2. Minus 5 add 4 is also negative. A negative times a negative is a positive. A number after minus 4, let's just pick 0. You get a negative times a positive. That's a negative. So it'll be the same on this side. And after 2, 3 minus 2 is 1. 3 add 4 is 7. They're both positive. Positive times a positive is a positive. So looking at our shape, we have got along, or then along, then down, or and then the second turning point, down, along, and then up. So the range of values for which the graph is increasing is just this one here and this one here. So it happens when x is less than minus 4 or when x is greater than 2. And we're done. Okay, stationary points and their nature. SQA Higher Maths 2017, paper 2, question 7. Find the x-coordinate of the stationary point on the curve with equation y equals 6x minus 2 root x cubed. Then find the greatest and least values of y in interval 1 is less than or equal to x and less than or equal to 9. So part A, stationary points occur when dy by dx is 0. So we need to get it ready to differentiate. So with part A, I've got y equals 6x minus 2. I've got x cubed, so the cubed comes along for a ride, but it's a square root, so it's over 2. The y by dx then, 6 minus 2 times 3 over 2, x to the half, because I take away 1 from the power, and then we can say that stationary points occur when the y by dx equals 0. So making this equal to 0, we get 6. These 2's cancel, so minus 3. X to the half equals 0. So 3x to the half equals 6. X to the half equals 2. Remember, x to the half means the square root of x equals 2. So I'm looking for, if I square both sides, I get x equals 4. And we're done there. Part B, hence determine the greatest and least values of y. So at x equal to 1, y equals 6 times 1 minus 2 times the square root of 1 cubed. 6 times 1, 6, minus 2 equals 4. At x equal to 9, the other one, y equals 6 times 9, minus 2 times the square root of 9 cubed. 6 times 9 is 54, minus the square root of 9 is 3, so 2 times 3 cubed. 54, 3 3's are 9 times 3 is 27, 27 times 2 is 54, that gives me a big 0 is the answer at the limits. So now I need to evaluate it at x equal to 4. So at x equal to 4, we've got y equals 6 times 4, minus 2 times the square root of 4 cubed. 24 minus 2 times the square root of 4 is 2, so 2 cubed. 24, 2 cubed is 8 times 2 is 16. 24 minus 16 is 8. So then we can just state our greatest and least values. The greatest value is 8 and the least value is clearly 0. So greatest value equals 8, least value equals 0. And we're done there. Stationary points under nature, SQA Higher Maths, 2019, paper 1, question 1. Find the x-coordinates of the stationary points on the curve with equation y equals a half x to the 4 minus 2x cubed plus 6. Stationary points occur when the y by dx equals 0. So we can find the y by dx. 4 times a half, well that's 2x cubed, take away 1 from the power. 3 times 2 is 6, so minus 6x squared, and then 6 goes to nothing. In our little statement, stationary points occur when the y by dx equals 0. We've got 2x cubed minus 6x squared equals 0. Common factor of 2x squared to get x minus 3. And that means that x equals 0 because 2x squared equals 0, or x equals 3. And there we are. Simple as that. Graph of the derived function. SQA Higher Maths 2019, paper 2, question 5. The diagram below shows the graph of a cubic with stationary points at minus 2 and 4 as shown on the diagram of your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic, so we're expecting a quadratic either going down the way or up the way, and we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when the y by dx is 0, which means that these are my roots. So I get a root at minus 2 and a root up at 4. So that means that if we examine before minus 2, it's going up the way, it's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before minus 2, it's below in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high, I'm dropping below between the numbers, and then I'm going high again, so my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the derivative. Paper 2015, paper 2, question 8 of the SQA Higher Maths. This is a crocodile stock in play located 20 metres further upstream on the opposite side of a bank. Crocodiles travel at different speeds on land and water. The time taken for a crocodile to reach its prey is minimised if it swims to a particular point, p metres upstream on the other side of the river as shown. And then it gives you a formula for the time taken in tenths of a second, given by this. Remember, x is this horizontal distance here. Part A says calculate the time taken if the crocodile does not travel on land. It was the context of the question, I think, that made this one difficult, and people couldn't quite understand what's it asking me here. Well, if it's asking me basically this, if it doesn't travel on land, it is in the water. If it's in the water, it's just swimming straight upstream at 20 metres. So part 1 actually is just substituting x equals 20 into this formula. So part 1, t of 20 is 5 root 36 plus 20 squared plus 4 times 20 minus 20. Well, that's 0. So that's just 5 plus the square root of 36 plus 400. And that equals 5 times the square root of 436. And that is 100. And once you get your calculator out, you do square root of 436, times it by 5, and you get 104. And just remember your units, it's tenths of a second. So that's part 1 done. Now let's look at part 2. Calculate the time taken if a crocodile swims the shortest distance possible. Well, let's have a look at this picture again. Swims the shortest distance. Well, a straight line is going to be the shortest distance. So if he just jumps straight up here and then walks the rest of the way, he must be walking 20 metres. So that means that he spends no time in the water. Because remember, x is how far he swam basically upstream. So he's not swum anything upstream, he just went straight across and he's went 20 metres on land. So in other words, x is 0. So for part 2, you just have to substitute t equals 0 in to the formula. So you get 5 times the root of 36 plus 0 squared plus 44, times 20 minus 0. 5 times 6 is 30, 4 20s is 80. That gives us 110 tenths of a second. Part B, although the context of the question was quite unusual, to say the least, between these two extremes there's one value which minimises the time taken. If you're a higher maths pupil, you should realise that the word minimise means we're doing optimisation. And that should be a big key red flag for you. Find this value of x and hence the minimum possible times. So step 1, I need to get it ready to differentiate. So if we look at our t of x, we can do the surds can come a power. So that's 36 plus x squared to the power of a half plus 80 minus 4x just by multiplying out the bracket. Now we can differentiate this using the chain rule for this part. T dash x is equal to 5 times a half, taking the power down, 36 plus x squared to the minus a half. And then we need to differentiate the 36 plus x squared because of the chain rule, so times 2x. And then we'll still have take away 4 on the end because that's 0 and that is differentiates to 4. Tidying that up, we get 5 over 2 times 2x. 36 plus x squared to the minus a half. Take away 4. 5 times 2 is 10. Divided by 2 is 5. So you've just got 5x for the first term. We could say that's over 36 plus x squared to the half minus 4, or that's 5x over the square root of 36 plus x squared, take away 4. Now we need to look at our stationary points because we're trying to minimise the time taken. So it's an optimisation question. So just remember, for stationary points occur when t dash x equals 0. So we've got our equation 5x over the square root of 36 plus x squared minus 4 equals 0. Okay, moving the 4 to the other side, we get 5x over the square root of 36 plus x squared equals 4. And then we can multiply through by the denominator. In other words, 5x equals 4 times the square root of 36 plus x squared. And we can square both sides to get 25x squared equals 16 times 36 plus x squared, because opposite of a square root is squaring. And we can work that out. 25x squared equals 576 plus 16x squared. Moving the x squared over to the other side, taking away 16, you get 9x squared is 576. So x squared is divided by 9, 64. So x equals 8 or x equals minus 8. But straight away, minus 8 is not valid because x has to be a positive number. X is greater than 0 or equal to. So x equals 8 is our number. So the minimum time taken occurs when x equals 8. There's no need for a nature table this one because we know it's going to be a minimum. So minimum time when x equals 8. So we can then substitute that back into our t of x. So remember that would give us t of 8 equals 5 times the square root of 36 plus 8 squared plus 4 times 20 minus 8. And if you were to work that out using a calculator, you would get 98 tenths of a second. Optimization SQA Higher Maths 2016, paper 2, question 7. It says, a council set aside an area of land to create 6 fence plots. Each plot has a rectangle measuring x by y, and it says the area of land being set aside is 108. Show that the length of fencing is given by this. So let's start working on the length first of all. And then we'll probably have to use the area to change our y to an x because this thing's only got x's in it. So our total length. So let's just count. We've got 1, 2, 3, 4, 5, 6, 7, 8y plus 1, 2, 3, 4, 5, 6, 7, 8, 9x. So 9x plus 8y or 8y plus 9x. But our length has got only x's in it, so I'm going to have to use my area. So if I look at the area, well, if I notice this is y and this is x and x, I've got 2y on the height and times 3x, length times breadth, on the bottom. So 2y times 3x is equal to 108. So that means that 6xy equals 108. So I can replace this y by dividing by 6x. Y is 108 divided by 6x. So I can do 108 divided by 6x. So that simplifies to 18 over x. So now for our length, L of x, which was 8y plus 9x, we can replace the 8 and the y by 18 over x plus 9x. And we're trying to make it look like 144 over x. Well, let's hope. 8 times 18. 8 8s is 64. 8 1s is 8. 8 plus 6 is 4. That's 14. So our length of x is equal to 144 over x plus 9x. Or to make it look exactly the same as we're given in the question, 9x plus 144 over x. And we're done there. Part B, L of x is equal to 9x plus 144 x to the minus 1, taking the x up. So L dash x is equal to 9 minus 144 x to the minus 2. Or we could say 9 minus 144 over x squared. Now, for minimization, we need to find stationary points. So stationary points occur when the derivative equals 0. So 9 minus 144 over x squared equals 0. And then we need to solve that equation. So timesing everything through by x squared, since we've got an algebraic fraction. Or we'll start by saying 9 is 144 over x squared, because that makes it simpler. So that implies that 9x squared equals 144. So x squared is 144 divided by 9. Let's just do that quickly at the side. We get 1596, 16. So x is the square root of 16. Which is equal to 4 because, and it's actually equal to minus 4 as well, or minus 4, but we'll just disregard it because x cannot be negative because it actually has a real length we're looking at. So we're just looking at that turning point of 4. So that's why you need to watch. When you do your turning points, if it's a real life question, you get a negative answer sometimes, you just disregard it. So looking at our table of signs, we've got x, we're going along to 4 and along, and then L dash x. Well, in the vicinity of 4, remember L dash x is equal to 9 minus 144 over x squared. So apart from 0, you can't pick 0. 3 3s is 9. 9 into 144 is 16. That's negative. 9 minus 16 is negative. So we get a negative. We get 0. And picking any number after 144, it should be clear that 9 minus a small number, because it's going to be a fraction, is going to be positive. So that means our shape is down, along, and up. And therefore, minimum at x equal to 4. And we're done there. Just a note on the table of signs. So if you'd use minus 4, you could have done along minus 4 along, but then you'd have to go along 4 along, and you'd have to still disregard that minus 4 because it can't be minus 4. So you're better off just disregarding it up here. But notice I don't pick numbers here, because if you try and pick 0, you're done. So I will always just draw an arrow to show that it's in the vicinity of 4.
Question carefully, it's really just an optimization question. Have a look, see if you can have a go at it, and then come back when you're done. Minimize the cost of production. Minimize optimization. That's your key power word for higher maths there. Let's try part A in any case. So there is our box and all the information in it, and I want the surface area. So I'm just going to start working on it and see if I can get the answer close to what we have got. So surface area, we've got 3x times h, and I can see I've got 1 of them, 2, 3, 4 of them. So first of all, I can write down, I've got 4 times 3x h. I'll put a dot for times in so it's clear. And then I need to add on, well, I've now got my top and my bottom. So my top is going to be 3x times 3x, so that's 9x squared, times that by 2, so plus 9x squared, plus another 9x squared, just to be clear, or 18x squared straight away. But then you've also got a whole in the top, which is x squared by x squared, and I've got 2 of them, so take away 2x squared straight away. And then the bit that everybody can't always forgets, I almost forgot it, there's a surface inside this tube as well. So I need to work out what that surface is. Well, there's going to be 4 of them, and it's just going to be x times h. So plus 4xh. Tidying all that up a little bit, my area is 12xh plus 4xh. That's just my first and my last one. And then my x squared is 9, 18 minus 2 is 16x squared. Or my area is 16xh plus 16x squared. If you can get that far, you're getting a mark. But we're not finished there because our area in the question's not got any h in it. So we need to work out if we can eliminate that h somehow. Well, let's look at the information. The volume is 2000. Well, volume is length times breadth times height. So if I write that down and underneath, volume is length times breadth times height. Volume of the big box, which is 3x times 3x, which is 9x squared times h. So 9x squared h, but we need to remember to take away the whole, which is x by h, so that's just x squared h. So our volume, 8x squared h, but that equals 2000, it says. So I can now eliminate h from my area by rearranging this equation to make h the subject. So that means that h equals 2000 divided by 8x squared. A mark for getting h. Now we just need to substitute it into a. So our a is 16x times h, 2000 over 8x squared. And we've got still plus 16x squared. Using a calculator, 16 times 2000 divided by a is 4000. So we get 4000 on the top. And we've got cancellation to do, x on the top, so x squared becomes x. So we get x on the bottom, plus 16x squared, or writing it in exactly the same way we wanted, 16x squared plus 4000 over x, which is just exactly the same as what I've just already got. And there's your third and final mark. Part B said, to minimise the cost of production, the surface area A of the box should be as small as possible. Find the minimum value of A. Minimum value optimization. Let's jump straight in. So part B, I want to optimize the area. To differentiate a function, we need to get it ready. So let's start with our area. We've got 16x squared, but I'm going to have to take that 4000 x to the minus 1, so I can differentiate it. And you'll actually get a mark straight away there for getting it ready. We now differentiate it, so a dash or a dash x, 2 16s is 32x minus 4000 x to the minus 2. And that's me differentiated it for a mark as well. So 2 marks out of 6 so far. Now if we fix that by making it equal to 0 because we're optimizing. So remember, stationary points occur when a dash x, I'll call it, equals 0. So we can say 32x minus 4000 x to the minus 2 equals 0. For realizing we had to do that and find stationary points, we get another mark. And then we need to solve it. We'll get another mark in a moment for solving it, but I'll show you all the working you need for solving it. So we've got 32x equals 4000 over x squared, we could say, x to the minus 2. So multiplying through by x squared, we get 32x cubed equals 4000. Dividing through by 32, 125. So x is the cube root of 125. There's only one answer to that. It is 5. So we now know that x is 5 is our turning point. But we need to prove and show that that is a minimum. We don't know if it's a minimum or a maximum. So we need to do a table of signs. So let's do our table of signs just to show that. X going along 5, and we're going along. A dash x, so a number less than 5, but not 0, because 0 it's undefined. Then if you picked 1, say, you would get 32 minus 4000 over 1. That's a negative. So we've got negative 0. Hoping that after 5 is positive, but you can check. Just get yourself a calculator, pick a number close to 5. Let's pick 6, say. 32 times 6 is 192. 4000 divided by 36 is 11. That minus 11 is positive, so we can say it's positive. So our shape is down, along, and up. Therefore, x equals 5 minimizes a. So to get a, remember, x equal to 5, we work out our area equals 16 times 5 squared plus 4000 over 5, 1200. For your final mark. A note in table of signs here. technically this is one of those ones where the function is discontinuous. In other words, at 0, because if you can't divide by 0, it breaks. You have to make sure that you have kind of shown that it's in the neighbourhood of 5. I always draw an arrow because the SQA take it to mean a number close to 5, a number close to 5 on either side. If you do that and don't actually say any numbers, you will be fine.
Question 8. A rectangular plot consists of a rectangular pond surrounded by a path. The length and breadth for x and y, and the path is 1.5 metres wide at the pond ends and 1 metre on the other sides, as shown. The total area of the pond and the path is 150. Show that the area of the pond is given by this equation. Well, we know the total area all the way round is x times y, or y times x. So we know, first of all, for part A to start with, that the area, total area y times x must equal 150, because it says so in the question, 150 square metres. If we go back up to the diagram, this distance here is going to be x minus 1.5 and 1.5, so 3. Similarly, going along the way, that distance there is going to be y minus, and you've got 1 and 1, so 2. So clearly the area of the pond part is y minus 2 times x minus 3. So the area of our pond, y minus 2 times x minus 3. We'll call that A. Now notice there's a y in here, but our question doesn't have any y's, but we know that y times x equals 150, so putting that back up there, y is 150 over x. Keep that in mind because we can substitute that in for y later on. Let's multiply our brackets out here. A equals yx or xy minus 3y minus 2x plus 6. Substituting our y in, which is 150 over x, we get 150 over x times x minus 3, 150 over x minus 2x plus 6. So that simplifies to 150 minus 450 over x minus 2x plus 6. So 150 plus 6 is 156 minus 2x minus 450 over x. That's now a function of x. And that's exactly as required. So we've done part A. Part B, determine the maximum area of a pond. This is called an optimization question. So in this case, we need to differentiate it and find the stationary points. So A dash x, we're going to have minus 2. And if I take a little note up here, minus 450 over x is minus 450 x to the minus 1. So we've got minus 2, then plus 450 x to the minus 2. Or, in other words, a dash x is minus 2 plus 450 over x squared. Clearly x cannot equal 0. So max or min stationary points we're looking for. So we want to set a dash x equal to 0. So that gives us minus 2 plus 450 over x squared equals 0. So multiplying through by x squared to eliminate the fraction, we get minus 2x squared plus 450 is 0. So 2x squared equals 450. X squared is 225. And therefore x is the square root of 225, which gives us two answers, plus or minus 15. X squared equals 225, so x equals 15. We can discount the negative value based on the question and do a nature table for just x equal to 15. So we've got x up to 15 and then at before 15. So at 15 we have got it being 0. If you pick a value before 15 but not 0, as you know, then you will see that you'll have 450 over 1, take away 2, which is positive. And if you pick a number after 15, let's just pick a massive number, 100. If we did 450 over 100 squared, that'd be a very small number. Take away 2, it's going to be a negative answer. So it's negative. So the max area, A of x, was equal to 156 minus 2x minus 450 over x. So at 15, we get 156 minus 2 times 15 minus 450 over 15. That's 156 minus 30 minus 30 again, which is 96, so meters squared. Now we move on to what I would say is unusual differentiation questions. The first one we're going to look at, just stuff that doesn't come up as often, is this one. A quadratic function is defined on a set of real numbers. This was 2017, paper 1, question 15. Diagram 1 shows the graph of y equals f of x with the turning point at 2, 3. And diagram 2 over here shows the graph of h of x, and the turning point is now 7, 6. Okay, let's see what it's asking us to do. Part A. Given that h of x is f of x plus a plus b, write down the values of a and b. So in other words, it's a graph transformation question for part A. So let's have a look to see what's happened. If we look at this point 3, well, let's just look at the turning point, 2, 3, it's clearly moved along to become 7. 2's become 7, it's moved to the right by 5. So if it's moved to the right, then A must be negative. So A is negative 5 because it's moved to the right by 5. If N or B, well, plus B on the end means it's moved, the whole thing's moved up by some number. We started at 3 and we've ended up at 6. 3 plus 3 is 6, so B is simply the number 3, and we're done there. So part B says it is known that the integral between 1 and 3 of f of x is 4. What is the value between 8 and 6 of h of x? Well, an integral means an area. So we know that the area under this bit here is 4. So that means over on this graph, since it's just moved up, this whole area here is also 4. And leaving the extra bit between 6 and 8 is just a rectangle. That is 2 along. And that must be 3 because the graph's moved up by 3. 2 times 3 equals 6, so our integral between 8 and 6 of h of x is just 6 plus 4, which equals 10, and we're done there. Part C says, given that f-1 equals 6, what's h-8? f-1 equals 6, let's just use a different colour pen now. That means that the gradient of the tangent at this point here equals 6, and it's asking us, what is the gradient of the tangent at 8? Well, at 8 on h of x, 8 is this bit here. Now that's, if we imagine looking at this graph instead, that would be this point here. It's a mirror of this, so it's sloping down the way. So it's just minus 6, because it's just the other side of the graph. So h dash of 8 equals minus 6, and we're done there. Unusual question, SQA Higher Maths 2018, paper 1, question 15. A cubic function is defined a set of real numbers. X plus 4 is a factor, x equals 2 is a root, f dash minus 2 equals 0, and f dash x is greater than 0 when the graph crosses the y-axis. X plus 4 is a factor means that x equals minus 4 is a root. That's where it crosses the x-axis. X equals 2 is a repeated root, which means that it's also a turning point on the x-axis. That's what happens when you've got a repeated root. So we can start drawing a graph. We can look at the other options in a minute. But if we draw a y and x-axis, just a quick sketch, we've got minus 4 as one of our roots, and we've got 2 is, I'll just put it here actually, as another root. And when looking at our derivatives, f dash of minus 2 equals 0. So we now know that at minus 2 at some point, we've got a turning point as well, not on the x-axis, but then we also know that f dash x is greater than 0 when it crosses the y-axis. So we know that it's going up at this point, but this is a turning point, so it must drop back down. So we now know that it must go like this. And we know that this is a turning point, so it must turn here and go up here because that's a root. So we've got a root, a repeated root, and we're done there. This has been Claire Maths, and today we've looked at the whole of differentiation in the SQA Higher Maths exams for 2023. Take care, stay safe, and goodbye.